Hello everybody and welcome to a lesson for Contemporary Math, Section 5A, Fundamentals of Statistics. In this lesson we will talk about statistics, how they work, how samples work, picking samples, what bias means. We will talk about different types of statistical studies and the placebo effect and blinding. So to start out, we have this prompt here. It says statistics plays a major role in our society. Some of the ways they are used, statistics are used, are, I think the most common one would be sports. Other ways they can be used are for market research, drug trials, or polls. Depending upon what time of year it is, you may be hearing about a lot of polls about how the president or local governor or mayor is doing. So what are statistics? Statistics is the science of collecting, organizing, and interpreting data, and the data that measure or summarize something. So both of these things are important. So we'll take a look at the first example, how do statistics work? Some of you may or may not be familiar with Nielsen ratings. And it's basically just a rating system to measure how popular shows are. So for example, you can see here, The Big Bang Theory was last week's most popular show with 22 million viewers. But what's really interesting about this statement is that you can see here, Nielsen ratings are used to estimate the number of people watching various television shows in America. They are based on data from only about 5,000 homes. So if there are only 5,000 homes using this Nielsen system, how can we say that there are 22 million people watching this show? Well, through statistics. In order to understand statistics fully, what that means, what they are, how they work, we need to understand the vocabulary that comes along with it. So we have the population in a statistical study is the complete set of people or things being studied. The sample is the subset of the population from which the raw data are actually obtained. So in addition to that, we have things called the parameter, or parameters are specific numbers describing the characteristics of the population, and statistics are the numbers describing characteristics of the sample. So one thing you can see here is that population and parameter both start with P. A statistic always goes with a sample. They both start with S. That's one way you can keep them grouped up in your head. So our first little example here, we have this. Describe the population, sample, population parameter, and sample statistic for this particular scenario. It says a Gallup poll of 1,051 American adults shows that 32% of Americans say they've been spending less in recent months and intend to make this their new normal pattern in the years ahead. So we're asked to find 4 different things here. So I think the sample stuff is normally easier to start out with. So the sample here consists of 1,051 American adults. And it's important to have this unit here, American adults. That way we know exactly who we're talking about. And the only other number that we have right now here is that of those 1,051 adults, 32% say they've been spending less money in recent months. So how do we generalize these to the population? So instead of there just being 1,051 American adults, we say all American adults, or just American adults. You don't have to use this word all. I chose to. The parameters here would be the true proportion. Proportion. Spending less. Remember, for a statistic, this is just our best guess based on information that we were able to draw. All right, so now we're going to go in choosing the sample. Like, how did the Gallup polling place pick these 1,051 Americans? Well, this is about choosing a sample. So choosing a sample, as you can see, may be the most important step in any statistical study. If the sample fairly represents the population as a whole, then it's reasonable to make inferences from the sample to the population. A representative sample is a sample in which relevant characteristics of the sample members are generally the same as those of the population. So since choosing samples, knowing how to choose samples, is one of the most important things we can do for a statistical study, let's take a minute and just take a look at common sampling methods. The first one is a simple random sample, and you can read this here, but it's more or less putting everybody's name or every object that you're looking at into a hat and just reaching in blindly and picking out a few names or a few numbers or a few items, and that's it. That's how you pick your sample. A convenience sample, use results that are readily available, aka you just ask the closest people around you. Systematic sampling is where you select every kth member, so it could be every third person, or it could be every 20th Chevy truck that comes off the line being checked for quality, so on and so on. Stratified sampling is what happens when you partition the population into at least two strata, aka two different groups, by some characteristic, and then you draw a sample from each group. So say there are 6 women and 6 men, you pick 2 women and 2 men from each group. You pick the same number from each group. So let's take a look at identifying what kind of samples are being chosen. So you're conducting a survey of students in a dorm. You choose your sample by knocking on the door of every 10th room. So you're skipping rooms in between, but every 10th room you're going to knock on the door and get a survey of this particular student. It sounds like this would be systematic. The second example, to survey opinions on a possible property tax increase, a research firm randomly draws the addresses of 150 homeowners from a public list of all homeowners. This sounds like they had the entire city or county's worth of homeowners, names, information, and they just put them all into the same pool and just randomly picked 150. This one would be a simple random sample. All right, watching out for bias. Suppose you want to determine the average height and weight of male students at a large university by measuring the heights and weights of a sample of 100 students. Would a sample consisting only of football players be representative of the population with respect to weight? And clearly no. I myself do not play football, and if they wanted to weigh all of the football players and come back and say, hey, the average for this whole university is 225 pounds, I am well below that. So I don't think this would make a lot of sense at all, because the football players are generally have more weight, bigger people than people who don't play football. So we can say a statistical study suffers from bias if its design or conduct tends to favor certain results. A researcher could be biased if he or she has a personal stake in the outcome of the study, like calling in to a Republican talk show and trying to answer a poll as to who would make a better president, the next Republican candidate or the next Democratic candidate. There would probably be some bias there. So this last question, why would television networks use Nielsen ratings rather than doing it themselves? I think it would make sense to say they would be biased toward high ratings for their own shows. They would definitely push their shows up the ratings list faster than they would any other station's shows. So now that we have some sampling ideas and bias ideas out there now, we can take a look at the different types of statistical studies. The first type we have here is an observational study. And in an observational study, researchers simply collect data based on what is seen and heard, and then make a conclusion. The other one here that we will be looking at is an experiment. And in an experiment, researchers will apply treatments to a group and record the effects. So here the researchers are actually doing something to the members in a group. And here the researchers are just collecting data, not giving them a drug or changing a component or anything like that. They're just collecting data and then making inference from there. So here are a couple examples. You can see observational study and experiment. So when you're working with an experiment, to determine whether an experimental treatment worked, you must compare groups that receive the treatment to those that don't. So this means that we will have to have two different groups, and sometimes it's more, but normally it's just two, and we will give those groups some names. So first we have a treatment group, and that's the group of sample members who receive the treatment being tested. And then we have the control group, and they don't receive the treatment. That way we can tell if the treatment works. So it is important for the treatment and control groups to be selected randomly and alike in all respects. So I have these filled in here. Need to be selected randomly and alike in all respects. Now, is that 100% possible that you get two groups of people, say for a drug trial, in that you divide them into two groups so that they match up exactly? There's a 70-year-old woman with cancer in this one and a 70-year-old woman with cancer in this one, a 50-year-old man that smokes in this one and a 50-year-old man that smokes in that one. It's probably impossible to get it 100% alike, but you have to do the best you can. That way you can have the best results. So down here we've got this last little bit called the placebo effect. And the placebo effect in blinding we'll get to. The placebo effect is very, very strong. So what it says is that people can be affected by their beliefs as well as by real treatment. And that is what we call the placebo effect. And the placebo just refers to a pill that looks like the other treatment, the actual treatment, but doesn't actually contain the treatment. So the people will get a placebo and think it's the real deal. And when that happens, if the people who are in the experiment, the members that are being tested, the treatment and the control group. If we keep them in the dark about who is getting the treatment and who is not getting the treatment, that is what we call blinding the experiment. And so, like, that is very, very powerful, because it has happened that people have improved their health on a placebo medication because they thought so hard and they just kept getting better and better. It's really just a fascinating topic. So, in addition to blinding, we can have multiple different ways of blinding. So an experiment is what we say single blind if the participants don't know whether they're members of the treatment or control group, but the experimenters do. And what's really crazy is we can have an experiment that is double blind, and in that one, the participants nor the experimenters know who belongs to the treatment or the control group. And you might be asking, well, how is that possible? Who's going to keep track of the people running the experiment and the people who are getting the treatment or are in the control group? If nobody knows, how is this going to work? Well, what will happen is, since someone has to keep track to validate results, researchers will hire contractors to help keep the statistics and keep record of everything that's going on. And that concludes the lesson for Section 5A in Contemporary Mathematics. Good luck.